So today we'll start with few problems on friction. Okay, let's start with the first one. The question is, what is the acceleration of the block and trolley system shown in the figure if the coefficient of kinetic friction between the trolley and the surface is 0.04? What is the tension in the string? So here we are neglecting the mass of the string and we are taking the acceleration due to gravity as 10 meter per second square for easier purpose. Okay. Now carefully look at the figure. See, you have a weight. You have the trolley, so that's 20 kilos, and then you have the tension of the string, and then you have a weight, so that is around 3 kg, correct? Correct. Okay, see, now first point about solving any of these type of questions is how tension, how gravity, basically the weight, whatever we are talking about, and the friction, how these three are related, we need to know. Okay, so this is what it means. Alright, so now see, for the trolley, two forces are acting on it. One is the tension, one is the friction. Right? So tension is coming this way and the friction is the opposite direction. Now for the weight which is hanging, two forces. Weight which is coming downwards and the tension which is upwards. Okay? Now let's see how to solve the problem. See, this string, it's basically inextensible, correct? So that means you cannot stretch it or you cannot squash it. It's like a normal string. Now, in this case, so 3 kg block, 20 kg trolley. Right? Now, what we'll do is, see, second law of motion. Okay, second law of motion, if we try to calculate, see, basically what was second law of motion? F is equal to ma, correct? Now, see, for that particular block, what we have, for the particular block, weight, what will be the weight? W is equal to mg, right? So W is equal to 3 into 10, that's 30. So the weight is 30 Newton. Remember, weight is a force, right? Now, for the 3 kg block, so weight is acting downwards, tension is acting upwards, correct? So that will become 30 minus T, right? So that's the force. So 30 minus T is equal to 3 into A. F is equal to ma formula. Right? Same way, we'll try to apply the same second law of motion for the trolley. Now, tension and friction are happening, correct? Those are the two forces acting on the body. So, T minus F is equal to 20 into A. Right? So, tension and force are opposite. So, now, Fk, so basically the friction is mu k into the normal n. Right? So that's the formula, right? Now, so mu k is equal to mu k, what is given mu k? 0.04 at 0.04. So n value becomes 20 into 10 because it's a 20 kilo trolley. So 20 kilo here, normal is above, correct? So 20 into 10 is 200. Right? So now what happens for the trolley, for this particular equation of motion for the trolley becomes T minus 0.04 into 200 is equal to 28. Basically, in place of Fk, we are writing 0.04 into 200. So, you'll get this as T minus 8 is equal to 28. Right? Now, see, we have two equations, correct? So, we have two equations and we have two variables, T and A. Now, use simultaneous equation. Okay, if you use simultaneous equation, you get acceleration as 0.96 meter per second square. Okay, 0.96 meter per second square. And the tension becomes 27.1 Newton. Okay, so whenever you have these type of problems where you have a pulley, two weights, and you have one string which is, they are stretching the string. If they are balancing out what is the tension in the string and what is the acceleration if they ask, this is how you solve. Okay, so go through the video again so that you understand how the problem goes.